Today we'll be doing the integral from 0 to 1 of the arctangent of x divided by 1 plus x dx. And to start, we will call this integral I, and we will parameterize this integral as I of s is the integral from 0 to 1 of the arctangent of sx divided by 1 plus x dx. And now we will differentiate both sides. So I prime of s will be the integral from 0 to 1 over 1 plus x, and the partial derivative with respect to s of the arctangent of sx dx, which is the integral from 0 to 1 over 1 plus x times 1 over 1 plus s squared x squared, and then the derivative with respect to s of sx dx. So this is going to sort out to I prime of s equals the integral from 0 to 1 of x divided by 1 plus x times 1 plus s squared x squared dx. And from here we'll use partial fractions. So a over 1 plus x plus bx plus c divided by 1 plus s squared x squared is our integrand, so x divided by 1 plus x times 1 plus s squared x squared. And from here we'll get a common denominator. So we'll have a times 1 plus s squared x squared plus 1 plus x times bx plus c equals x. So expanding this, we have a plus as squared x squared plus bx plus c plus bx squared plus cx equals x. And now we will combine like terms. So x squared will have as squared plus b. Collecting the x terms, we have b plus c, and then the constants a and c equals x. So for this equation to be true, as squared plus b must be 0, b plus c must be 1, and a plus c must be 0. So solving for these, we have a equals negative c, and b equals 1 minus c. And plug it into this equation, we'll have negative cs squared plus 1 minus c equals 0. And then we'll have negative c s squared minus c equals negative 1. Factoring out a negative c, we have negative c s squared plus 1 equals negative 1. These negatives will cancel. We're left with c equals 1 over s squared plus 1. But we said a equals negative c, so a equals negative 1 over s squared plus 1, and b equals 1 minus c, which will turn out to be s squared divided by s squared plus 1. So these are the constants of our partial fractions. So we just got done showing that I prime of s is the integral from 0 to 1 of x divided by 1 plus x times 1 plus x squared times x squared dx. And the following constants, a equals negative 1 divided by s squared plus 1, b equals s squared divided by s squared plus 1, and c equals 1 over s squared plus 1. And our integral satisfies the following conditions. I of 0 is 0, and I of 1 is the original integral. So then from here, we will plug in these constants. So I prime of s is the integral from 0 to 1, x divided by 1 plus x times 1 plus s squared x squared dx, which is the integral from 0 to 1 of a over 1 plus x plus bx plus c divided by 1 plus s squared x squared dx, which is equal to the integral from 0 to 1, negative 1 divided by s squared plus 1 times 1 over 1 plus x plus s squared divided by s squared plus 1 times x plus 1 over s squared plus 1 divided by 1 plus s squared x squared, all of this dx. And from here we could factor out 1 over s squared plus 1 term. So this is the integral from 0 to 1, negative 1 divided by s squared plus 1 times 1 over 1 plus x plus 1 over s squared plus 1 times x times s squared plus 1 divided by 1 plus s squared x squared, all of this dx. And we could break apart this fraction even further. So we have the integral from 0 to 1, negative 1 divided by s squared plus 1 times 1 over 1 plus x, and then plus 1 over s squared plus 1, x s squared divided by 1 plus s squared x squared, plus 1 divided by 1 plus s squared x squared dx. So we have the integral from 0 to 1, negative 1 divided by s squared plus 1 times 1 over 1 plus x plus s squared divided by s squared plus 1 times x divided by 1 plus s squared x squared. So I'm just distributing here. And we'll have a plus 1 over s squared plus 1 times 1 over 1 plus s squared x squared dx. So we now have I prime of s is negative 1 divided by s squared plus 1, the integral from 0 to 1, 1 divided by 1 plus x dx, plus s squared divided by s squared plus 1, the integral from 0 to 1, x divided by 1 plus s squared x squared, and plus 1 over s squared plus 1, the integral from 0 to 1 of 1 divided by 1 plus s squared x squared dx. So we left off with these three remaining integrals, and now we will evaluate each one. So for this first one, it's negative 1 over s squared plus 1, the integral from 0 to 1, 1 over 1 plus x dx, which is equal to negative 1 over s squared plus 1, the natural log of 1 plus x from 0 to 1, which is negative log 2 divided by s squared plus 1. So replacing that, we have I prime of s is negative log 2 divided by s squared plus 1 plus s squared divided by s squared plus 1, the integral from 0 to 1, x divided by 1 plus s squared x squared dx plus 1 over s squared plus 1, integral from 0 to 1, 1 divided by 1 plus s squared x squared dx. Now for the second one, we have s squared over s squared plus 1, the integral from 0 to 1, x divided by 1 plus s squared x squared dx. And we will make a substitution. We'll let u equal 1 plus s squared x squared, which means that du over s squared times 2x equals dx. And the bounds of integration, u sub 1 will be 1, and u sub 2 will be 1 plus s squared. So this is equal to s squared over s squared plus 1, and then the integral from 1 to 1 plus s squared of x over u du 2s squared x. The x's will cancel. And as you can see, this s squared will cancel with this s squared, and we're left with 1 over 2 times s squared plus 1, the integral from 1 to 1 plus s squared, 1 over u du, which is equal to 1 over 2s squared plus 1, the natural log of u from 1 to 1 plus s squared, which will be the natural log of 1 plus s squared divided by 2 times s squared plus 1. So I prime of s will now be negative log 2 divided by s squared plus 1 plus 1/2 the natural log of s squared plus 1 divided by s squared plus 1, and then plus 1 over s squared plus 1, the integral from 0 to 1, and let me see what it was, 1 divided by 1 plus s squared x squared dx. And now for this last third integral, it's 1 over s squared plus 1, the integral from 0 to 1, 1 divided by 1 plus s squared x squared dx, and this is equal to 1 over s squared plus 1, the integral from 0 to 1, 1 divided by 1 plus sx quantity squared dx. And we can make a simple substitution here. So we can let u equal sx, which means that du over s equals dx. The bounds of integration, u sub 1 will be 0 and u sub 2 will be s. So this is equal to 1 over s squared plus 1, the integral from 0 to s, 1 over 1 plus u squared du over s, which is 1 over s times s squared plus 1, the integral from 0 to s, 1 over 1 plus u squared, and that's going to be an arctangent from 0 to s, which is an arctangent of s. So this is arctangent of s divided by s times s squared plus 1. So that means that I prime of s is negative log 2 divided by s squared plus 1 plus 1/2 the natural log of s squared plus 1 divided by s squared plus 1, and then plus the arctangent of s divided by s times s squared plus 1. We now have that I prime of s equals the following expression, and it satisfies the condition I of 0 is 0 and I of 1 is our integral. So now all that's left is to integrate both sides from 0 to 1. So the integral from 0 to 1 of I prime of s ds equals the integral from 0 to 1 negative log 2 over s squared plus 1 plus 1/2 the integral from 0 to 1, the natural log of s squared plus 1 over s squared plus 1 plus the integral from 0 to 1, the arctangent of s over s times s squared plus 1. And notice that the integral from 0 to 1 of I prime of s would just end up being the original integral. So our integral is negative log 2, the integral from 0 to 1, 1 over s squared plus 1 ds, and then plus 1/2 the integral from 0 to 1, natural log of s squared plus 1 over s squared plus 1 ds, and plus the integral from 0 to 1, the arctangent of s over s times s squared plus 1 ds. And this integral, this fairly standard integral, it will turn out to be negative pi over 4 log 2. So their integral is negative pi over 4 log 2 plus 1/2 integral from 0 to 1, natural log of s squared plus 1 over s squared plus 1 ds, plus the integral from 0 to 1, the arctangent of s over s times s squared plus 1 ds. Now for the second one, it's going to be 1/2 the integral from 0 to 1, the natural log of s squared plus 1 over s squared plus 1 ds. We'll make a substitution, so we'll let s equal the tangent of theta, which means that ds equals secant squared theta, and that also means that theta is the arctangent of s, and theta 1 will be 0, and theta 2 will be pi over 4. And also notice that s squared plus 1 is the tangent squared plus 1, which is also secant squared. So is equal to 1/2 the integral from 0 to pi over 4 of the natural log of secant squared theta divided by secant squared theta times secant squared theta d theta. But these cancel, and we're left with 1/2 the integral from 0 to pi over 4 the natural log of this secant squared theta d theta. And you can notice that you can bring this 2 to the front, but it would just end up canceling this one. So we're left with the integral from 0 to pi over 4 the natural log of the secant of theta d theta. But we could rewrite this as the integral from 0 to pi over 4 the natural log of 1 over the cosine of theta, which is negative the integral from 0 to pi over 4 the natural log of the cosine of theta d theta. But I actually did an integral on this in a previous video, and it sorts out to be the integral from 0 to pi over 4 the natural log of the cosine of theta d theta ends up being negative pi over 4 log 2 plus Catalan's constant over 2. So we're going to have a negative pi over 4 log 2 plus Catalan's constant over 2, which is pi over 4 log 2 minus Catalan's constant over 2. So our integral now becomes negative pi over 4 log 2 plus pi over 4 log 2 minus Catalan's constant over 2 plus the integral from 0 to 1 the arctangent of s divided by s times s squared plus 1 ds. And we have some nice cancellation here. So our integral is now negative Catalan's constant over 2 plus the integral from 0 to 1 the arctangent of s divided by s times s squared plus 1 ds. So we finally have their integral is negative Catalan's constant over 2 plus the integral from 0 to 1 the arctangent of s divided by s times s squared plus 1 ds. And to start off, we can make yet again another substitution. So I'm going to let s equal tangent of theta, which means that theta is the arctangent of s. Theta 1 will be 0 and theta 2 will be pi over 4. But this means that the arctangent of s will be the arctangent of the tangent, will just be theta. So this now becomes I is negative Catalan's constant over 2 plus the integral from 0 to pi over 4 of theta over tangent of theta, and s squared plus 1 will be secant squared theta times secant squared theta. And I forgot the ds, but ds would just be secant squared theta. So times secant squared theta d theta, and the secant squared ends up canceling, so we have negative Catalan's constant over 2 plus the integral from 0 to pi over 4 of theta cotangent of theta d theta. Now from here we could use integration by parts. So I'll let u equal theta, which means that du equals d theta. Let dv equal the cotangent of theta. So the integral of cotangent is the natural log of the sine of theta. So our integral is now negative Catalan's constant over 2 plus theta, natural log of the sine of theta from 0 to pi over 4. Then minus the integral from 0 to pi over 4 of the natural log of the sine of theta d theta. And now evaluating this limit, we have I equals negative Catalan's constant over 2 plus pi over 4 and the natural log of the sine of pi over 4, which ends up being the natural log of the square root of 2 over 2. And as theta approaches 0, that whole limit will end up being 0. So we have minus the integral from 0 to pi over 4, the natural log of the sine of theta d theta. And we could clean up pi over 4 natural log of the square root of 2 over 2. So we can rewrite pi over 4 natural log of the square root of 2 over 2. Using logarithm rules, we have pi over 4 log root 2 minus the natural log of 2, which can be pi over 4 the natural log of square root of 2 minus log 2. But this has a 1/2 power, so this is pi over 8 log 2 minus pi over 4 log 2. And getting a common denominator, we have pi log 2 minus 2 pi log 2 divided by 8, which is going to be negative pi log 2 over 8. So our integral is negative Catalan's constant over 2, and then minus pi log 2 over 8, and minus the integral from 0 to pi over 4, the natural log of the sine of theta d theta. And now to solve this last integral, well, if we recall from a previous video, if I sub 1 is the integral from 0 to pi over 4 of the natural log of the cosine of theta, and let's say j sub 1 is the integral from 0 to pi over 4 of the natural log of the sine of theta d theta, we had the following system of equations. The I1 plus J1 ended up being negative pi over 2 log 2, and the I sub 1 minus J sub 1 ended up being Catalan's constant. So our goal is to solve for J sub 1. So to do that, if we solve for I sub 1 in this equation, I sub 1 is Catalan's constant plus J sub 1. Plugging into the other one, we have that J sub 1 plus Catalan's constant plus J sub 1 is negative pi over 2 log 2. So you have a 2 J sub 1 equals negative pi over 2 log 2, and minus Catalan's constant, but solving for J sub 1, which is going to be our integral. So J sub 1 is 1/2 negative pi over 2 log 2 minus Catalan's constant. So J sub 1 is negative pi over 2 times 2 log 2, and minus Catalan's constant over 2, which is negative pi over 4 log 2 minus Catalan's constant over 2. So our integral, if we recall, we had negative Catalan's constant over 2 minus pi log 2 over 8, and then plus J sub 1. No, it was going to be a negative J sub 1. So we have I is negative Catalan's constant over 2 minus pi log 2 over 8, and then minus this expression, negative pi over 4 log 2 minus Catalan's constant over 2. So our integral is negative Catalan's constant over 2 minus pi log 2 over 8, and then it would be plus pi over 4 log 2, and plus Catalan's constant over 2. But the Catalan's constants over 2 just end up canceling, and we're left with negative pi log 2 over 8 plus pi log 2 over 4. We could get a common denominator here, so multiply both sides by 2. That means that I equals negative pi log 2 plus 2 pi log 2 over, the common denominator is 8, so we have pi log 2 over 8. So we could say now that therefore the integral from 0 to 1 of the arctangent of x divided by 1 plus x dx is pi log 2 over 8. And so this is the final result. Thank you very much for watching.